Hey, Larry. It's so good to see. It's been a while, mate.
Yeah, it's been a while. It's been a while.
It's been a while. And I was looking forward to you trying to pronounce my last name, and then you
Yeah,
then you
I
chickened
decided. I
out.
yeah, I decided. You know what? Instead of trying to do that and biting up my tongue, let me let him say it.
No, it's good to see you.
Yeah, it's a
It's
pleasure.
lovely. I'm looking forward to this.
Yeah, I mean, before we get into this, though, before we get into your whole thing today, I've been, as you know, I keep track of what's going on, and we have this whole thing on your on what's it called, your API. What's it called? Rest assured 2.50. What's how's that been? I mean, before we jump into what we're gonna talk about it, just
Um, so that started out as just a little. I was trying to look for a project that helped me improve my development skills, and then I'm um, pretty active in the whole API testing, automation stuff. And I love C Sharp as a programming language. So I thought, why not combine those three and see if I can bring it. So I love Rest Assured. Um, and I thought it would be a nice, even if only just for myself, just a nice exercise to bring that to the C Sharp ecosystem.
okay.
So yeah, that and also because there's a couple of libraries in that ecosystem already that can help you do API testing. But as I said, I really like Rest Assured and the way it allows you to write tests that are very readable and expressive. And I thought, well, there's probably room for one more in the C Sharp ecosystem there as well. So, and it's still relatively early stages, even though we're already at 2.50. Probably tells you more about the bugs that I still need to fix and all that stuff and all. But yeah, it's fun.
And that is the most important. The most important thing is that it's fun and that you're doing it
Yeah,
because it's something you love, and it make things easier for you. And as you say, you can never have enough. And if you can make somebody life somewhere that's a little easier sometimes, then we're good
it's
to go.
it's that's probably the most fun part. Yeah, the reaction that I get to people. Oh, this is actually pretty useful. So yeah, that's awesome.
All right. Well, I mean that's cool. So so what I will do now is give you the whole floor for yourself, and then after all for the audience there, if you have any questions, just pop them in the chat, and I will ask them to I pass them on to Basas when he's finished. All right. So
So, like with all of my talks, Larry, I have no idea how long I'm going to take exactly with the demo and stuff. So, could you please warn me if we've got like 10 minutes left because I want to reserve that for the Q&A. If I'm
that's
not done yet, and because the last thing I want to do is eat into Tobias's time. So
yeah, no problem at all. So I'll give you. I'll put that 10 minute. I'll put that 10 minute clout on you. So that give you enough time for Q&A.
sounds like a plan.
All
Okay.
right, then.
I'll just go. Larry, can you quickly confirm that you can see my screen?
Let me see. I'll let you know. Yes, I can see a screen.
Awesome.
All right, guys. So without further ado, I'll please leave the floor open. Bas, the floor is yours.
Thank you so much, Larry. And thank you to everybody who joined us. I was going to say good afternoon because it's afternoon over here, but maybe it's good morning, maybe it's good. I don't know. Just good day. Um, you probably. My name is Bas Dijkstra. I live in the Netherlands. I've been in testing and automation for some 17 years now. I'm an automation consultant and trainer. Um, and I would like to talk to you today about mutation testing. As Larry already said, there will be a live demo of how mutation testing works, what you can do with mutation testing, how it's different from just measuring code coverage. But before we dive into the fun stuff and the practical stuff, I want to talk to you a little bit about why it's important to test your tests, because that's essentially what mutation testing is doing. It's a technique supported by tools to help you test your tests. Um, So the whole reason behind this talk and this story, and why I think mutation testing is so interesting as a technique, is because this is what our life as testers but also as developers looks like right now. We're testing everywhere and all the time. We're testing in a local development environment, we're testing in production, we're testing in any stage or environment that's in between those two, and we test all the time. And why? Because we want fast feedback. We want to get information about what's the quality, or what's the quality of the product that we're building, or what's the impact on the quality of the latest change, of the latest added feature, refactored code, whatever change has been introduced to your code base by a developer. We want to have feedback about the impact of those changes on the quality of our product all the time, and we want it fast, which is why we spend so much time, first of all, testing, and then making the testing more efficient and effective through use of tools, which means automation. And so we spend a lot of time, and you'll probably recognize this because the demand for automation and people who are skilled at automation has only been rising ever since at least ever since I started in this field somewhere in 2006. Um, and it doesn't seem like we're at the end yet. Um, so we and teams and organizations spend a whole lot of time and effort writing tests. And one of the questions that is on my mind, and not just on mine, but on minds of lots of other people as well, is um, but what about the quality of those tests? So we talk a lot about all the automation that we do, about coverage, about how much of our regression set we have automated. But I don't think we talk enough about the quality of our automation, about, are we really testing the things that we think we're testing? Are we really verifying the things that we think we're verifying with our automation? And why is that so important? Because the more we move towards this, let's call it a continuous testing model, for, well, if we want to give it a name, um, the more, the bigger the role, the bigger the part that automation plays in this role, the more important the quality of that automation becomes. And especially because the more we move towards a continuous delivery model for a software delivery, the more we rely on the information that's provided by our automated tests. The more often we make decisions on, is this a good is this change meeting our expectations? Is this change meeting our requirements? um, did we not introduce any unexpected side effects or bugs? The more we move towards a continuous delivery, the more often it's our automated tests that are the only, well, guards, really, safety nets, gatekeepers, quality, whatever you want to call it, between a developer making a change on their local development environment, and that change, that updated code, um, being exposed to our end users in a production environment. And so the more we move towards continuous delivery, the more often our automated tests are the only source of information, the only safety net with regards to quality, which means I think it's very important to make sure that those guards can be trusted. And which is why I think we need to talk a little bit more often about what's the quality of the automation that we write. Because those automation, those tests can deceive us, they can fool us, they can fail us. And that's typically in, you see that in one of two forms. The first one is the false positive, which In my definition, and in a definition of a lot of other people as well, sometimes people get them confused. That's okay, as long as everybody agrees on the definition. But for me, a false positive is a test that fails when your application works as expected, which means that your test fails due to either you coding or creating the test incorrectly, or due to some unforeseen side effect, for example, through timing, through data, or through something downstream in your test environment, maybe. So yes, some of these tests you'll see failing each and every time, which my response would be, well, fix it or just throw it away. That's a way of fixing it as well. Maybe not the best way, but it's a way of fixing it. So just fix it. But more often you see those tests that fail sometimes and then pass, and that's what people call a flaky test. A test that produces different results um, when your application is in the same, even though your application is in the same state. Um, and these are annoying. So one solution to this, and please don't ever do this, is just to retry your test and say, well, I'm going to retry it 5 times, and if it passes once, then we're okay. The problem is, it might pass once, but it fails 4 times, and that is telling you something. It's either telling you something about the quality of your application, but more likely it's telling you something about the quality of your test. And that's something that should be addressed because your tests should be reliable. Again, think they are the guards of your application code. So again, these false positives there's different reasons for these false positives to occur. It's often something to do either with test data not being present either in the system you're testing or into some connected system. It might be something with the test environment, and with some downstream servers acting funny. Um, and it might be something to do with timing and synchronization. Especially, and we see this especially often in UI automation, um, where it takes you just a little bit longer than you waited for an element to appear, or for an element to become clickable, or for a page to load, or for whatever kind of event to occur in your UI. And so these are very common sources of these, well, flaky tests. Um, the other form of untrustworthy tests, tests that fool you, is the false negative, um, which is, well, the polar opposite of a false positive. A false negative is a test that passes, but they don't detect a change in your code that they were supposed to detect. Um, and while false positives are annoying because they say, well, I failed, I'm annoying, I failed. Um, at least they make themselves known. They present false positives, present themselves because they turn up in your pipeline, in your test report, in whatever way your tests communicate about the results. False negatives are those tests that say, I'm okay, I'm okay, I'm okay, when there's a problem that they just don't detect or don't report. And so these false negatives are what I call silent killers, because there's a change. Your test was supposed to detect them, it didn't detect them, and if you but well, if your tests don't detect them, probably at some point your users or your customers are going to detect it. And I think, well, that's not a good thing. So let's look at a quick example. I've got a class that represents a bank account here with a type and a balance, a constructor, and a simple method that adds interest, but only to accounts of type savings. This is a very naive implementation. Bear with me. I'm making a point here, not showing off my coding skills. I've also got a test that tests this add interest logic, so that creates a new account of type savings, deposits something, adds interest, and checks the resulting balance. Um, this is the way we typically write tests and think, well, that's okay. And we say, well, our test pass and we have 100% code coverage. We must be doing something right. Um, and you might be doing something right, but metrics like this, metrics like code coverage, can fool you, and it can fool you quite easily. And that's the whole point of this example, really. Because now, just imagine after a very long and relaxed weekend, a developer comes in, um, decides to either add another feature or to refactor some code that they wrote well before the weekend, and now they think it's ugly, so they want to improve it and refactor it. Um, but they make a mistake. Um, if there are developers in the audience, I'm not talking about you, I'm talking about other developers, not you. You don't make mistakes. But anyway, that developer comes in, starts adding some feature, rewriting some code, refactoring some code, and they accidentally make a mistake. So that instead of only adding interest to accounts of type savings, and they rewrite that expression so that it always evaluates to true, meaning that now we can add interest to all kinds of accounts, which is probably mostly as a bank is something you don't want, or at least, well, unless it's in your requirements, but well, it's probably not something that you want. Um, but we have our tests, right? So our tests should pick this up. Our tests should inform us about any unwanted changes or and signals. Well, hey, so this is something that probably went wrong. The problem here is if we run that test again, it still passes, and we still have 100% code coverage. So even if we think, well, we've got a set of passing tests and we're covering all of our code base, there's still a whole lot of things that can go wrong. And which is why Martin Fowler already said, and I'm just stealing this from him, test coverage can be code coverage, but so in this example, it's code coverage, but I'm talking about all kinds of coverage, really. It's a great way to identify code that has not been tested or has not been exercised by any kind of automated test yet. As a quality target in and of itself, as a means of talking about the quality of the testing that we do, it's pretty useless. And I hope this example, again, it's very simplified, but I hope this example shows you that, well, this is probably not a good way to talk about the quality of our testing. Um, So, what can we do to trust our tests again, or to increase the trust in the tests that we write? Testing your tests. That's what it comes down to. And we need a way, we need a mechanism so that we can test our tests. One of the best ways to do that, I think, is to do pair programming when you write your tests. And which means you have a second or third or 15th pair of eyes on the screen and on the keyboard when you write your tests. Um, if that's, well, if you don't like it, don't prefer it, or are unable to do that, there's also an asynchronous way of pair programming, code reviews. I much prefer doing synchronous pair programming, really. But if you say, well, I don't like that, I don't want it, my company doesn't want it, code reviews are also a good way to get a second pair of eyes on code. And that applies to, we developers have been doing this for ages on application code, but well, test code is code too, and it's important code too. So why not practice the same thing for our tests? Um, so pairing and code review is typically something that you do when you create your tests. It's probably also a good idea to periodically go through your test suite and say, well, are these tests still making us happy? I don't want to go all Marie Kondo on you, but um, it's probably a good idea to periodically go through your test suite and see, are these tests still making me happy? Are they still effective? Are they still giving us relevant, important, and trustworthy information. And if not, well, do something about it. Either improve the test, refactor the test, or just throw it out. And so review that test suite often, and don't be afraid to throw tests out. And don't be fooled by the sunk cost fallacy, meaning, well, we spent so much time writing these tests and now you're telling us to throw it away. Well, if it doesn't bring you value anymore, it's probably better to just say goodbye and throw that test out. Um, that sounds like a lot of work, and it is. Um, the good news is there are tools that can help you do that. There are tools that can help you test your tests. There are tools that can help you analyze your test suite and give you information about the quality and effectiveness of those tests, which is where mutation testing comes in. So, why talk about this? Maybe I think it's very, it's first of all, it's a very interesting technique, I think, and it's also pretty powerful and can produce some very interesting results that things like just uh, humans looking at code or techniques metrics like code coverage just cannot uncover as easily. Um, so, what is mutation testing? Mutation testing is a technique again supported by. You can do. You can pretty much do mutation testing sort of kind of on with pen and paper, but it's probably much more efficient to do it with a tool. Um, so what a mutation testing tool does, it takes part of your code base and it inserts small changes in it. In mutation testing terminology, it creates mutants. It creates those mutants in memory, by the way, so it doesn't actually change your source code, but it creates an in-memory copy with a small change. That small change can be it removes a call to a method that returns a void. It flips a binary operator. It flips a boolean. It initializes a variable with a default with a hard-coded value instead of a dynamically calculated value. All examples that we are going to see in our in the demo in a moment. So it creates mutants. So that copies in memory copies of your code with small changes injected into that. And then it runs your tests against those modified versions of the code. And if at least one of your tests is failing, which means at least one of the tests detects that change, that's a good thing because now you know that your test can detect changes, which is what, especially what automated tests are all about. They are change detectors. They are not bug finders. They are change detectors. Um, but if all tests are passing on on a mutant, which means that none of your tests picked up that change, that's worth an investigation. It might mean that um, you're touching some code that's not really relevant or important. But it could also very well be that your tests just aren't as effective as they should be. So that there's some room for improvement in your tests. Um, now I'm going to slowly move towards the hands-on live demo part, and I'm going to do that with PyTest. PyTest is a mutation testing library for Java. Um, all of the concepts, all the things you see, they apply to all kinds of mutation testing tools, all kinds of programming languages. Why Java? Because it's a very popular programming language, of course. And why PyTest? Because it's one of the few mutation testing tools that are actively supported by industry in the Java ecosystem. Um, a lot of these mutation testing tools originate from academic research, and that's fantastic. It's that's a great source for a lot of tools that we use these days. However, a lot of these tools are typically used for research for a couple of months or maybe a couple of years and then sort of kind of abandoned. And then also not always as easy to use. PyTest is easy to set up and is easy to use because it's been adopted by the industry. It's open source, which is also a nice thing to have, and it's pretty easy to configure. If you want to know more about PyTest, well, just look at the website. This is how you configure. I think I'll just move to the live demo part. So for the live demo, Larry, can you just quickly confirm me that you're still hearing me fine?
Yes, I can see the code fine. Looks good.
Awesome. No need to increase the font size?
Just give me a sec. It's not showing up on my thing here. Give me a sec. And I can see it clean on my side. It's readable.
Okay, awesome. No, let me just to be sure, increase it a little
Yeah,
bit.
do it about 14. Yeah.
There we go.
All right. Yeah, that's much better. Yeah.
So I've got a s- um, a class again, a class representing a bank account here with some just a slightly more extensive version of the example that we saw on the slides. So I've got a constructor. It's good to know that if you create a new savings account, the initial balance is 10, and for a checking account, it's 0. And we've got some logic to deposit, to withdraw, and to add interest. I've also got a bunch of tests here. And let's see. So the first stage in mutation testing is always just check if the tests are passing. Because um, if your tests aren't passing, it's useless to run mutation testing because, well, how are you going to determine the quality of a test that's not even passing in the first place? But in our case, we've got 7 tests and all of them are passing, which means it's time to do our first mutation testing run. What I've done in this project, by the way, this project is available on GitHub. I'll show you the link to that in a moment. I'll also paste it in the chat after the talk is done, so you can have a look for yourself. PyTest is available as a Maven plugin. The only configuration I did here is I said, well, please use the default set of mutators, so the default set of changes it'll make. By the way, those changes are deterministic. So if I run mutation testing, if I run PyTest on my test suite 10 times, it's going to create the same changes all 10 times. So there's no randomization involved there, which makes it very easy to reproduce all the stuff. And I just said, well, please pick everything from the examples cover everything from the examples patch. And basically you tell here what's the code that I want to mutate and where are the corresponding tests. This is the command that you use to run PyTest. Just believe me for now. So this creates the mutants in memory, runs the tests, and reports on the results. So let's have a look at the results. Those end up in pit reports in my target folder, and they show up as a nice HTML report. So before I dive into the details, just remember we've got 52% mutation coverage and 65% test strength. If we look at the details, we'll see this is the information that a mutation testing tool produces. Green is good, as usual, which means that light green means this code was covered by the tests. So mutation testing does code coverage and more. Darker green means I've made a change in this line and that change was picked up by one of your tests. Similarly, light pink means this code was not covered by any of your tests. And dark pink means I made a change here, but that wasn't picked up by any of your tests. So looking at the light green, let's cover the code coverage. Let's get the code coverage stuff out of the way first. Um, it tells me that, well, basically this whole method was never invoked, and that's true because if we look at the code here, we can also see, well, it's never called. So let's just remove that. And then there's another part here, another line here. That's never invoked. And if we take a closer look at our tests, indeed, we don't have a test that tries to call the add interest method on an account of type checking. So there's no test that checks, is this type of exception thrown when I try to call the add interest method on an account of type checking. So let's add that to our suite. I'm just going to use some test for the exception. Yes, I know I should think of a better test name, but and we want that on a checking account, and then I want to assert that if we call the add interest method on that account and IntelliJ tells me, well, I can even replace that with a method reference. So this test creates a new account of type checking and then checks that whenever I call the add interest method on that account, that should throw an exception of type add interest exception, which is exactly the case that is mutation testing tells us, well, you didn't cover that yet. Let's see first if our updated test suite and our updated code have our updated tests pass. Yes, well, we've now got 8 tests instead of 7, which is good. And we still have a passing test suite. So let's see if there's any improvements in our mutation testing score. Yep, that's the updated version. Let's open that in a browser as well. Now instead of 50, this was 52 and 65, and it's now 60 and 71. So we have improved. And indeed, well, that whole print transaction thing is now gone. And this part, which was marked as not covered here, is now covered. And we even know, and mutation testing even tells me, well, this is a pretty effective test because what I did was I replaced the equality check with false, which is one of the many mutators that are included in the default mutator set. So it just replaces this expression with something that always evaluates the false. Which means that if false, then throw the exception. Well, so it never throws the exception. And that was picked up by one of the tests, and more specifically by this test, because this test verifies that the exception is thrown, which means that this change was detected by this test, which means that this gives us a good indication, not just that our test covers this code, but also that it's able to detect unwanted changes in this code, which is, well, at least a reasonable indication that we have an effective test here, and more so than just relying on the code coverage. Awesome. Um, let's look at another kind of change or mutation that went by undetected. Let's look at this one. So, what this line of code says is basically this spells out you cannot overdraw on a savings account. Meaning that if you want to withdraw an amount that's larger than the current balance, and the type of the account is savings, it should throw withdraw exception. So it's a slightly more complex guard clause. Um, what it says, well, I've made PyTest has made 3 changes, created 3 mutants here. It removed this conditional and replaced that with false. That was killed, meaning our test, one of our tests picked up on that. The same for this clause; it replaced this with false. Well, one of those tests, well, probably the same, uh, also picked up on that one. But there's a third one. It changed that's the first one listed here. It changed the conditional boundary, and that mutant survived, meaning that none of the tests picked up on that change. What does it mean when it says I changed the conditional boundary? Um, it replaced this greater than operator with a greater than equal to operator. How do you know that? Well, I looked at the documentation. Um, so that's what this mutator does. So it tries to find greater than or smaller than operators and replaces them with either a greater than equal to or smaller than equal to. Meaning that these changes are great ways to say, do you do effective testing around the boundaries of your around your boundary values, basically. Turns out our test suite doesn't. And we all know, as testers and hopefully also as developers, it's those boundary values where often the most interesting things occur. Um, Turns out that mutation testing told us we don't do very effective testing around our boundary value. Luckily for us, again, this is a pretty straightforward project and it's pretty easy to fix this. So if we look at this test, we try to withdraw from a savings account, which is again what we're talking about here. I created a new account of type savings. Again, the initial balance is 10 for the savings account. I withdrew 5 and I checked that the resulting balance, the remaining balance, was also 5, which of course is not a test around any of the boundary values for this piece of business logic. If I simply replace this with withdrawing everything and then checking that the remaining balance is equal to 0, which is exactly at the boundary of what we are allowed to do here. Um, let's first check our test again, our test suite again. That obviously passes because basically, well, 10 minus 10 is still 0. But if we run our mutation test again on our what we think is an improved test here. Also, instead of rewriting this test, I could have just generated another test case. That's another way to address this. It that all depends on whether the initial test case, so the initial example test case, test data set, whatever you want to call it, is significant or important to you. In this case, for me, it wasn't, so I just replaced it. I could have also addressed this by adding another test next to the one that withdrew 5 and checked for the remaining balance to be 5. If we open the latest version of our report, we can now and look at. I see that where in the previous run this conditional boundary change mutant survived, it was now also killed because we have a test that more effectively tests around our boundary values. These two are very similar. That's homework for you. Again, all of the code is on GitHub, so feel free to. I'm not going to be able to, just looking at the time, not going to be able to get to 100% mutation testing score, also because I want to um, talk about where to use it and where not to use this for a couple of minutes and still leave some time for Q&A. But there's one final change that I still want to discuss, at least one mutant, and that's this one, and also this one, because they're essentially the same. Because what happened here is this is a method. If we look at our code, it's a method that doesn't return anything. It just adds a transaction to a list. Basically, it creates an audit trail, a history of all the transactions that were performed on this account. Pretty useful thing to have, I think. However, what our mutation testing tool tells us here, that's all well and good, but I've removed this entire method call. I removed the call to add transaction to list, and none of your tests picked up on that. Which means, and I'm not going to add that to the test suite. I just want to use that as another example of the type of change that mutation testing tools make. Probably your application code will do lots of these things. Call a method that doesn't return a value, but that performs some kind of transaction. If you do that, if you have those kinds of method calls in your application code base, and you probably have lots of them, you probably want your tests to verify um, whether those method calls actually did what you think they did. And in this example, our tests don't, because there's no if you look at the code in a little bit more detail, again, that's homework for you, you'll see that at no point is there does any of these tests check, well, does this transaction that we performed, this deposit or this withdrawal, does that actually end up in the transaction list? And so again, that's a different type of change, a different type of change that a mutation testing tool can make, and a different type of, I wouldn't call it a test defect, but a different type of room for improvement for your tests. So if your tests, and because this code is covered, again, you can see it's in light green. It's marked in light green, which means it's all well and good. This code is exercised when you run your tests. It's just that the effects of this method call are never verified in any of your tests, which are two pretty different things. And this is what, again, where code coverage falls short. Just measuring code coverage falls short, but mutation testing can help you identify these, call it weaknesses in your test suite. All right, back to the slides and time to wrap this up. Basically, I hope that this talk and especially this live demo demonstrated to you that, well, mutation testing tools can do things that code coverage tools do and more. Which is why mutation testing is such an interesting technique, because it can really tell you very interesting things about your code base. Um, does that mean you should all use mutation testing tools each and for every test run on all of your code? Probably not. Basically, don't mutation test all your code. Why? Because first of all, there will be lots of code, and we didn't really look at that. That looks more like this. And this is just a transaction class that represents some kind of domain entity. In program terms, that can be a DTO or a model or a DAO, data access object, data transformation object, whatever. Um, there's often not a lot of logic in these in these classes, which means you probably want to exclude them from your mutation testing efforts because, well, yeah, I replaced this with a null. It's probably not something that you want to address, or at least not what you want to address immediately. So, also, another thing to keep in mind is that mutation testing is pretty computationally expensive, meaning I've got a very small code base and a very small set of tests in this example. Real life code bases are much larger, real life test suites are much larger, which means that if you have much more code, um, a mutation testing tool will create many, many, many more mutants and run all of your tests all of the time against each of those mutants. So you probably want to be picky and selective with where you apply mutation testing. So, like with so many things in software development and in life, just start with a tiny piece of your code. See what value mutation testing brings, and then learn from that. Um, keep what's good, throw away what's bad, and increase your efforts. And I found this mutation that it works especially well if you're testing things like algorithms, things like business logic, business rule implementation, um, and where you have lots of, if this then that, or guard clauses, or calculations, all those kinds of things. That's probably also the code that you want to test as best as you can and as efficiently as you can. And those are also the areas in your code where mutation testing probably will provide the most value for you. That's it, basically. As I said, if you want to try out mutation testing for yourself, all of the code that I've shown is on GitHub. You can find it in this repository you see on screen right now. And if you have any, of course, we're going to the Q&A right now, but if at some point you have a question about anything mutation testing or test automation in general, just about life or whatever, you can find me on the internet and you can always send me an email. Thanks. Over to you again, Larry.
There we go. Yeah. Yeah, thanks. Yeah, well done with that, Bas. I've been, it's truly, instructive for me as well because I've never. I mean, I hear about mutation testing and and all this stuff, but I never really, pay much attention to it. So it's more about. Correct me if I'm wrong. It's more about testing the test, the ability to test your tests following that kind of example.
It is, yes, it is absolutely. It is absolutely about getting insight into the quality of the tests that you write. Yes, and it's again, it's a tool that can help you do that. So I think that's exactly what makes it so interesting.
And how do, I mean, you tell us on how do, let's say I want, is it specific? Like, is it a specific language? Is it language specific or it's?
Yes. So I used PyTest, which is a tool that's very specific to Java. And because how these tools work, they basically make small changes in the bytecode of your application, which means in the case of Java, it mutates the class files, which means it has to have very specific knowledge about what the code looks like and the structures that you use in the code. So they are very programming language specific. Um, so PyTest is very much a Java tool. The good news is that there's at least one, and in most cases, many different mutation testing tools available for other languages as well. So if you use JavaScript or you use C Sharp, there's Striker with a Y. That's a good example of mutation testing tools for those languages. There's you've got, I think it's called MutMut. I don't know. I don't make up these names for Python.
Yeah, I know.
So there's there's tools that can do, and the concept is very similar. So they make these small changes, run your tests, see if any of your tests picks up on the changes, and if not, it reports on that, which gives you something to investigate.
Okay, interesting. Um, I don't. I've seen a lot of people. I'm not sure if. Yeah, I'm not sure what how they perceive it, and I see everybody sharing on the task bar. At the moment, I haven't seen any specific question to the whole mutation thing, but I have a question from one of them about rest assured and rest sharp. And yeah, and rest sharp. What's the whole difference of the variation between them?
Ah, um, that's a good. That's I think I saw that appeared in the chat just before I started the talk. Yes. So again, that's completely unrelated um to the talk, but I'm more again. I wrote restassured.net, so I'm more. So I'm not saying you should use rest assured instead of rest sharp because, well, I don't really like those my tool is better than your tool discussions. Um, and rest sharp is a fine tool. It's been around for ages. It has features that rest assured doesn't have, or at least not yet. Um, One of the things I think rest assured does a little better than rest sharp is readability of your tests. So rest sharp is a general purpose HTTP client. It's a wrapper around system.net.htp for C sharp, which means it can be used in your tests. I've seen a lot of people write tests with rest sharp, and you can do that. And I've seen it used lots in applications as well. Um, what I like about rest assured for Java and what I try to bring to the C sharp ecosystem is the ability to write readable tests for your HTTP based APIs. And I think it does that a little bit better than REST Sharp. But again, that doesn't mean that it's a better tool. I just think that's one of the benefits of using REST Assured in Java and then also REST Assured.net in C Sharp is it allows you to write readable tests with relatively little code.
Okay, and now I think yeah, so. I have a question, literally, and it's a, if there is not much logic, like if else, while etc. In the testing code, will mutation testing be useful?
Um, it can still detect some things that you might want to know about. Um, I think one of the areas where it does very well is in around that business logic, around those conditionals. but it would still allow you um, to find if your tests are actually verifying the effects of calls to methods. So at that final example that I talked about that transaction being added to a transaction list, that's just a method call that's somewhere. But the result of that call was never. It turns out it was never verified in any of our tests. Um, and that's information that I think is still good to know, and maybe something you want to improve on in your tests. And that applies to tests where you exercise business logic, but also to other kinds of tests.
Okay. Um, okay. I mean, very informative as always, and yeah, we just watch this, as the people say, watch this space and see how it goes. And I will definitely, because like I say, I didn't know much about it, so I'll definitely look out for one of those JavaScript tools that will do it, and see how it, how it implies into my little world of JavaScript world. So thanks for that.
So yeah, no, you should check out Striker with a Y.
Yeah,
It's one of the um, most often used ones in that space. I'm not really active in the JavaScript space, but I know of that one. Um,
I'll definitely have a look.
awesome. So I also see a lot of comments about people talking about the quality and the connection breaking up. Did you experience that as well, Larry?
Oh no, we didn't. We didn't. Me personally, I didn't get it, but apparently, like, it corrected itself as the time went on. So everything was fine, and and things. So, and the comment people, a lot of comments coming in now, as you can see, about the whole. It's good to know about mutation testing, and
Yep.
we're gonna look into that. They're gonna look into that deeply as well.
Yes.
So yeah, very good.
Unfortunately, my time is up right now, and again, I don't want to eat into Tobias's
Yeah.
time, but I'm more than happy to take those questions either via email or on LinkedIn or well any other way. So, thank you so much. Thank you everybody for taking the time out of your day. Larry, thank you for
It's always a pleasure, Bas.
facilitating,
Always a pleasure.
and I'll leave it to Tobias now. Cheers.
All right. Yeah. Thanks. Thank you.